All right, so I just wanted to go over just a couple more examples of what we did yesterday. Yesterday we talked about correlation, okay, in some scatter plots. So here's some scatter plots. Your correlations can either be positive, negative, or no correlation, which means the two things just aren't related. And yesterday in our notes we said anytime your scatter plot looks like the points are just all over the place, that would be no correlation. So in this case, the first graph, those points are everywhere. That means that there is no correlation. In the second graph, you'll notice that pretty much the points seem to be going downward, okay? If they are following a downward trend, that means they have a negative correlation. In the third graph, for the most part, my points are going up. That would be positive. And then in the fourth graph there, if they're not going down or they're not going up, in this case, they're all in this area, but since they're not going down and they're not going up, that means this must be no correlation. Okay. Now, for this part, I put some more word problems on here because I noticed on yesterday's worksheet several of you were missing these. Think about this, okay? Your positive correlation, positive means, and I'm going to write this over here, positive means both are increasing. Both things are increasing. Your negative correlation means one increases, and that causes the other to decrease. And then obviously no correlation means these two things are not related at all to each other. Okay, so that's what you're thinking about. That's what you're looking for. Okay, so if I'm looking at these word problems, number one, you're always comparing two things. Number one, you're comparing the number of songs downloaded on your iPad and the memory available. Now, always think about this. If one of those things increases, what does that make the other one do? In this case, if you increase the number of songs you download, then the memory available will decrease. The more songs you download, the less memory you have available. So if this one increases, causing this one to decrease, that would be an example of a negative correlation. Okay, number two, the age of a house, how old your house is, compare that to the number of people living in the house. Do those two things have anything to do with each other? If the age of the house increases, does that mean the number of people living in the house is going to increase? No, that doesn't have anything to do with each other, so this would be no correlation. Okay, for number three, we are comparing the amount of time spent studying for a test, how much time you study for a test, and then the grade you score on the test. So theoretically, if you increase how much time you spend studying, if you study more and more and more for a test, shouldn't that make your grade also increase? If you increase your time studying, your grade will increase. So if both of those are increasing, then that is a positive correlation. Okay, number four, we might have talked about this one yesterday, I don't remember. But you're comparing the age of a car, how old a car is, to the value of a car. Now think about this. I don't know if you guys know much about cars, but the older your car gets, if the age increases, if the age of a car increases, generally what happens to the value of the car is it goes down, right? The older your car is, the less money it's worth. Unless you're, in a specific, maybe like a muscle car or a antique that's worth a lot of money. Overall, just normal cars, the older a car, the more the age increases, the less the value of the car will become. So this one increases, causing this one to decrease. That means this is a negative correlation. Okay, number 5. The amount of food consumed or eaten and the weight of the person consuming all that food. So if this one increases, what will happen to the weight of the person? If you eat more food, probably your weight will increase. So if they both increase, that is a positive correlation. Okay, and then the last one, the temperature in Boston compared to the rainfall in Detroit. Obviously, these are two completely different cities, so those really don't have anything to do with each other. There is no correlation in those. Okay, so that's what we talked about yesterday. On the back of this, real quick, I got a couple of scatter plots that I want us to look at and answer some questions about. So on number 1, this scatter plot right here is showing the number of lawns mowed by a local lawn care business during 1 week. So down here, if after 1 day of work, they had mowed this many lawns. After 2 days of work, they had mowed this many lawns. 3 days, and so forth. By the end of 6 days, they had mowed over 40 lawns. Okay, so first question, using the graph, how many days does it take to mow 30 lawns? So 30 lawns, we're going to find over here 30 lawns right there. That would be this point, and it took them 4 days to mow that. Now, about how many lawns can be mowed in 1 day? So we're going to go down here to 1 day, and we're going to guess about, that's between 10 and 15. A little closer to 10, so I'm going to say about 12. About 12 lawns. Okay, and then to write one sentence to sum up the graph data. Look, I don't want you to tell me this graph shows the number of days and the lawns mowed. That's not what I'm asking. I'm asking, what do the actual points tell us? So what you want to do is you want to see what kind of correlation is it. This would be a positive correlation, which means the more days that are worked, the more lawns that are mowed. So that would be a good sum right there to sum up this graph. The more days worked, then more lawns will be mowed. That should be pretty obvious, because if you work only 1 day compared to 6 days, in 6 days you can get a whole lot more done than you can in 1 day. All right, example 2, we've got a scatter plot here that shows the relationship between the number of girls and the number of boys in 10 different classrooms. So down here we got girls, over here we got boys. What type of correlation is seen? You should be able to tell that these points are just everywhere. So that means there really is no correlation. And think about your classes in the past, or this year, or if you're virtual, in the past, the number of girls in a classroom and the number of boys in the classroom really don't have anything to do with each other. That's just completely random. And so then to write a sentence to sum up this data, that's what we're going to say. It doesn't really matter how many girls are in a classroom. That doesn't determine how many boys are in the classroom. So I'm going to say they don't have anything to do with each other. The number of girls and boys in a classroom really have nothing to do with each other. Again, I'm looking for a broad statement that tells me what's happening here. Don't tell me, one class has 12 girls and one class has 12 boys. That's not a sum of everything that's happening. Overall, these points are all over the place, so who knows how many girls and how many boys might be in a classroom? They don't have anything to do with each other. That's what I'm seeing in this graph. All right, and then the last graph here, we've got it shows the relationship between the number of hours a student watches TV and then his or her test score. So down here we've got number of hours watching TV between 0 hours and 10 hours. And this only has 5 and 10, but this looks like it's counting by ones. That might help us to put those in there. Over here we've got test score, and this looks like it's counting by 10s, 20, 30, 40, 50, 60, 70, 80, and 90. That might help you to put those in there. So according to the graph. If a student watches TV for 5 hours, we're guessing about, what test score would they make? So come down here, 5 hours. 5 hours, there's not a point. You'll notice there's not a point on this line. So we're going to guess, all right? If I did have a point in this line, it would be somewhere in here, right? Somewhere in that area. So I'm going to say 5 hours would mean about, maybe a little over a 60. So I'm going to say about a 60%. Maybe a little more than a 60. But this point right here pretty much fits my trend or my data, so I would say that that would be a good guess. According to the graph for number 2, according to the graph, if a student wants to score an A on the test, about how much TV can they watch? So an A would be a 90 or 100. So I need to find something in this range right here, which this is really my only point, and that is about, if I follow this down, somewhere between 1 and 2 hours. So I'm going to say about 1 to 2 hours. If they watch any more than 2 hours of TV, the grades automatically start to fall. Okay? And then the last one, sum up the graph in one sentence. So again, overall, look for your correlation. This is a negative correlation. So, the more TV you watch, most likely what happens is the worse and worse your test score gets. So that would be my, my sentence. I'm going to say the more TV watched, means the less score on a test. That doesn't really sound right, but you get what I'm saying. The more TV you watch, the less score, or the lower score, that's what I'm going to say, the lower score on the test. There you go.